Hello, students. We will start with the next lecture now. In the last lecture, we have seen that there are different kinds of hypothesis, that is question form hypothesis, declarative hypothesis, directional hypothesis, and non-directional hypothesis. And we have also seen example of each of them. That is the question form hypothesis. Does intelligence affect the academics? So this is the question form of question form of hypothesis. And here you are not supposed to write the question mark at the end. Then in declarative statement, we have seen the example of the academic achievement of extroverts is significantly higher than that of introverts. In directional hypothesis, caffeine is linked to an increase in activity. And in non-directional hypothesis, there is a relationship between caffeine consumption and reaction time. So this all examples we have seen in the last lecture in detail. Now in next, we are going to see characteristics of good hypothesis. So following are the characteristics of good hypothesis. Good hypothesis is in agreement with the observed fact. So whatever fact you are observing, it is not rejected in your hypothesis. Those are accepted. Those are in agreement with the observed fact. So you're not going to say something opposite to what you are observing, right? Then it does not conflict with any law of nature. So whatever law of nature or whatever theory has been proved till date, till now, it will not make any conflict with that theory or with that law of nature. Then it is stated in a simplest possible form. So it should be a very simple statement. It should not be very complex and confusing statement, as you have, it should not have dual meaning as well. So it permits the application of deductive reasoning, in the sense it should allow researcher to do the research in a qualitative way, and most importantly in a quantitative way, because whenever something is measured by collecting the data, that is always a very solid research, or you can say that always have a very good proof about the research. So it, whatever hypothesis is there, it should be in such a way that researcher could able to do the quantitative as well as qualitative research. Then it ensures the method of verification. So whatever researcher will do, whatever methods researcher will do, another person, if he or she will do the same, that can be verified. Those results can be verified. Those methods which the researcher have used can be verified. So if it is possible, if such hypothesis is there, then only it will go into the into the level of good hypothesis. Then the next is whatever hypothesis you are preparing, it will guarantee you that whatever available tools and techniques you need to use, and you can use them effectively, and they will be having availability. So you can, whenever, as we have seen in the last lectures, that whatever problem you're going to design, at that time always you need to think that whether these all tools, techniques, instruments are available for me or not, and accordingly you are going to you are going to think about your research problem, or you are going to plan about your research problem. So automatically a good hypothesis must make sure that all these tools, techniques, even instruments are available, and of course you can it can be get very easily verified. So if another person does it, the purpose of verification for any another person should be available, they can do it. Then it ensures that sample is readily approachable. So whatever sample you're going to select for particular research, it should be easily available. Then it also indicates that the role of different variables are involved into the study. So always in research, as well as in making hypothesis, in making research design, it is very important that how many variables you are using, You must use one or more variables, and each variable must have some relationship between them. So that all can be verified by the good hypothesis. And good hypothesis also mention a very apparent distinction between theory, law, facts, assumption, and postulates. So although all these theory, law, facts, assumption, and postulates are considered when you are preparing a hypothesis, still it is having apparent distinction from it. So it is showing that yes, I'm following everything, I'm accepting everything, I'm agreeing with all theory, law, facts, assumption, and postulate, but yet my research will give another good solution, and it is distinct from all other theory, law, facts, assumption, and postulates which are available. Then what are the variables in hypothesis? As we have seen that it must have some variables whenever a research has to be done. So how many variables should be there? So there are 5 types of variables: independent variables, dependent variables, moderator variables, control variables, and intervening variables. Now, what is the meaning of, we will see one by one each. So what is the independent variable? So these independent variable are, you can say, stimulus variable, which is always used or which can be measured, manipulated, or selected by the researcher to determine the relationship to the observed phenomenon. Although it is going to measure, manipulate, or select or selected by the researcher to determine the relationship, at the same time it will stand alone, or it will stand as a independent variable. Nothing is dependent on it. So for example of this, I can say, or I can say that in a hypothesis, the dependent variable is what we expect to affect the independent variable is what we expect to affect the dependent variable. So it will affect, but it will still remain standalone. In a sense, that is, independent variable aren't affected by any other variables that the study measures. So it is not going to affect, or they are not going to affected by all other variables. They will remain as it is. So, for example, if someone was studying the effect of toothbrushing on incidence of caries, caries is decaying of tooth, the toothbrushing would be independent variable here, right? What they are studying? They are trying to study the effect of toothbrushing on the incidence of caries. So it is not always like that, that the toothbrushing is responsible for the caries, but at the same time, the caries, that is decaying of the tooth, is definitely dependent on the toothbrushing, right? So thus independent variable is the variable that is or that is not getting affected by any other variable, and it stands alone. Then the dependent variable, independent variable, it is a response variable or output, you can say. So it shows always the relationship between one dependent variable and a single independent variable. So there will be always one dependent variable and a single independent variable. Now, what is the example? For example, if you eat more vegetables, you will lose weight faster. It's correct, right? If you eat more vegetables, you will lose weight faster. Now, here, eating more vegetable is independent variable, while losing weight is dependable variable, because eating vegetables is going to give you benefit of all other vitamins and everything, right? But when the weight which is going to get decreased is completely dependent on what kind of vegetables you are eating, or how many vegetables, in what quantity you are eating the vegetable. Accordingly the weight will get you will lose the weight, right? So this is how it is called as dependable variable. Now the next is the moderator variable. Now here it is defined as the factor which is measured, manipulated or selected by the researcher to discover whether it modifies the relationship of independent variable. It is very important whether it could able to modify the relationship of independent variable. Now what it means? You can say that a moderating variable is the one that modifies the existing relationship between the independent and dependent variable. Now, for example, while social media use can predict levels of loneliness in relationship may be stronger for adolescents than for elder adults. So here, age is the moderator, right? Or I can give you another example, that is in a study on work experience and salary. So you are going to study on work experience and salary. So what you hypothesize that years of work experience predicts salary when controlling for relevant variables. In a sense, gender identity moderators the relationship between work experience and salary. So this means, what does actually it means? That the relationship between years of experience and salary would differ between man and woman. So that may differ. So this is what is called as, and the age. Age is, you can say, or the years of experience, you can say, is the moderator here, right? Then the control variable. It is defined as the variable whose effect must be mentalized or cancelled by the researcher. So what does it mean? It means, for example, or just to control variables directly, all you need to hold them constant throughout a research or whatever experiment you are doing. Now, to control them indirectly, you can use methods like statistical control. So here, statistical control you can do. So for example, in an experiment, suppose you want to observe the growth of plant, the temperature can be classified as a control variable. So you are taking temperature is the main control variable. If it is controlled during an experiment, of course, so you have to control the temperature. It should not increase, for example, not more than 28. So every time you have to control the temperature, right? So that can be act as a control variable. So that variable which you are going to keep it as it is, you are not going to change it into your throughout experiment, that can be said as control variable. For other examples of control variable can be the amount of light for that particular experiment, then duration of the experiment, how much time you are going to study the effect of that particular effect on that particular plant, then amount of water, how much you are giving to that particular plant, then the pot of the plant, means the soil actually, how much soil you have used to do that or to grow that particular plant, to do that experiment or to grow that particular plant. So that is what is called as control variable. Now in the next, we are going to see what is intervening variable. Now intervening variable is a variable with an abstract scientific concept that scientists invoke to label or summarize relationship between independent and dependent variables. So somewhere this intervening variables are like that, here scientists are going to summarize the relationship between independent variable and dependent variable in a particular circumstances or in a particular situation. So the common example of this intervening variables can be given as a gravity, thrust, learning, and intelligence. Now, to understand it in a better way, I will give you one example. Like, for example, Sleep problems in university students are often influenced by factors such as stress, right? So they are having stress, so they could not able to sleep well. So as a result, now what will happen? As a result, stress might be an intervening variable. So what is intervening variable here is stress, because it plays a role in how much sleep people gets, right? So how much people are sleeping, how you're going to find it out, how you're going to find it out that people are not able to sleep properly, it is because of stress. So which may influence, I mean the stress may influence how well they perform into the exam. So how you're going to measure it, maybe by measuring their performance into the exam. So stress intervening relationship between sleep and performance into the exam. Now, next is formulating hypothesis. So whenever you need to formulate the hypothesis, it is always suggested that you have to formulate it in inductive and deductive way. It means it should be in a qualitative as well as quantitative way. So, and it should be enable the researcher to generalize their finding. It should not be very, very specific and very narrowing to a particular subject, right? And always in hypothesis, you are formulating some or anticipating some findings. So it is always advisable that you should demonstrate the basic of whatever research you are going to do. And this is also always advisable that you need to study and discuss whatever hypothesis you are formulating with your peers or with some experts, because they will give you a fine toning to that, and they will give you good suggestions which will help you to formulate your hypothesis properly. Now next is testing the hypothesis, where you're going to test your hypothesis, test of validity, whether whatever hypothesis you have done, it will get accepted. Whatever problem you're trying to solve, will it get accepted or rejected? That is what is actually called as testing of the hypothesis. And of course, the testing of the hypothesis is merely a probability. It may or may not be, and it is supported by the fact, because you have taken some fact into the consideration, and on the basis of that you are hypothesizing it. Sorry. So you are not going to prove your hypothesis, right? Either your hypothesis will get modified, you can modify it if you find that it is not getting accepted, it is getting rejected. It means there is some issue in whatever problem you have studied or you want to study, right? And so that you can modify it, or it gets simply rejected, or it gets simply accepted completely. So that is what is when this is happening, whether your hypothesis is getting accepted, rejected, or modified. You can say it is called as testing of the hypothesis in a very simple word. So I will play video regarding it. Just enjoy the video.
By now, you probably realize that a big part of science is testing out your ideas. If you're going to test out an idea scientifically, you need a hypothesis, and your hypothesis needs a rationale. So let's think of a hypothesis. This little boy is wondering what would happen if he fed his amoebas twice as much. To make a hypothesis, you have to turn the question you're asking into a prediction of, if I do this, this will happen. You need both parts. In this case, this boy is going to make a bet that twice as much food will give him amoebas that are twice as big. What's great about this hypothesis is he knows exactly what he's testing for. He's testing the size of his amoebas. He can measure that, and so this is going to be an excellent hypothesis to work with. But the next thing he needs is a rationale. Why does he think that this is what's going to happen? A rationale is just an explanation of where your thinking comes from. This little boy's thinking comes from his own experiences. He knows that when he was a baby, his mom fed him, and he got bigger. So he expects that the same thing will probably be true of amoebas, which are also living things. Let's define these two interrelated terms. A hypothesis is a prediction about what you think will happen during a scientific test. A rationale is an explanation of your reasoning behind your hypothesis. You can't have one without the other. By now,
So you have seen one video right now which is telling you about hypothesis and rationale. Why rationale? Because many a times you will come across with this word rationale when you are doing your research. So just to uh, realize you that what is the difference between these two, I have put this video. Now this is another video which you are going to enjoy now. Now these are again the different types of hypothesis. Whenever there is null hypothesis, there is no correlation between variables. So now we are going to see the next part, that is experimental design. And I think it's better we could start it into the next lecture. So we will see in the next lecture that how you have to prepare experimental design. And we will also discuss about this cartoon in the next lecture. So we'll stop here. Thank you. Bye-bye. Take care.